Hello, everyone. It's great to be here at South by Southwest London. Fantastic event. I've been a visitor to South by Southwest in Austin for many years, so it's wonderful to see it in London. Before we get started, I've got some breaking news of my own, which is that I've left TechCrunch, and TechCrunch will sail on into the future, and I will sail on in a different direction. But there's more on... Thanks, mate. There's more on my LinkedIn, but enough about me. Alex, Kendall, you have raised over $1 billion to back your self-driving startup, Wayve. For those of you who are not familiar, there's been an enormous debate about how you do self-driving, but one of the newest entrants and in Europe and in the world, Wayve, having raised $1 billion, is started with a PhD in 2017. Tell us the story.
Yes, well, 8 years ago. So, all of a sudden now everyone's talking about AI and how it's disrupting the world. But 8 years ago, that really wasn't the case. And we saw headlines that said, look, billions of dollars raised to deploy self-driving next year. But these were robots that largely operated in pre-mapped environments where they were told how to drive following set rules. And just like we've seen in many different applications of AI, like game-playing agents, like language, or the game of Go and things like this, expert systems are being completely disrupted by end-to-end deep learning. So I think robotics is going to be no different. We're going to see learning systems that can develop an understanding of the world that's much more performant than anything we can hand code or tell these vehicles how to drive. And so 8 years ago, or even longer than that, through my PhD, I think we quickly developed the realization that this was going to be the case in self-driving.
I don't want to interrupt.
Well, I was just going to finish the very quick 8-year story.
Yeah.
We started building that, and then 8 years later, today we have an AI that can. In the last month, I've driven it in Germany, Japan, the US, and here it's driving around the world in different types of vehicles, and it's going to provide the way to let this technology scale.
But it all started. You put cameras, ordinary cameras, quite dumb cameras, on a little, what's it called, a Tizzy?
Renault Twizy.
A Renault Twizy, sorry, and drove it around Cambridge. Did you sit in the back? Did people look and see a self-driving car wandering around? Because you released a video and we wrote about it on TechCrunch. They must have been completely bemused.
I remember that first year was amazing because we took this vehicle and built a bunch of demos for the first time. So reinforcement learning, the idea of learning through trial and error, had only really been done. AlphaGo had just happened. It was done on an enormous scale using simulation and different trials with millions of examples to learn how to solve the game of Go. And that was hugely inspiring to us. What we were able to show was how do we bring this technology onto a real-life physical robot? The difference being in the game of Go, you have a small dimensional input. In self-driving, we have 7 or 8 cameras, maybe some radars. These are tens of millions of numbers that get input to the model, to the AI model. And so very high dimensional space, of course, very safety critical applications. And we're able to show that this could actually work. But what's really interesting today is that today car companies are building this hardware into their vehicles. So we have car manufacturers around the world. They call this a software-defined vehicle, where vehicles now have a central computer in them. They have surround sensors, surround cameras. So if you go to somewhere like Shanghai or San Francisco, you'll see some robotaxis that are available there. But these cars typically have lots of LiDAR sensors on them, lots of retrofitted equipment to them that makes it very obvious they're a self-driving car. If you look at the cars that we run, you may not notice that they're self-driving because we use the integrated production sensors, and these vehicles are being produced at millions of unit volume. So we really see this as an AI that can now integrate into all kinds of vehicles and work with the sensors they have on board to create all kinds of autonomy experiences, from driver assistance to driverless robotaxis.
So do you think that in the future, as you said, we won't be able to tell the difference between a fully autonomous car and maybe just a normal one?
Or I go further, I'd say, would you buy a car today without a seatbelt? I think self-driving is going to be so transformative that we just simply will see the consumer demand for vehicles that don't have self-driving will drop to near zero or maybe zero. In fact, if you think about autonomous driving, the technology we're building can enable vehicles to drive autonomously at a very cost-effective manner. Compute and sensors, maybe you're talking about $1,000 of hardware into the car, and this software can really scale, enabling different types of vehicles to drive with the ability to go in roads they've never been in before. I was in Japan a month ago, and we just launched our cars in Tokyo. We'd never been to Tokyo before, and I saw our car learn very quickly to follow local road rules. We even had this Japanese police officer jump out in front of us and say, "Stop," and we responded to their hand signals. But the most interesting scenario in Tokyo was they have a bunch of people driving in little Mario Karts, little go-karts dressed in Pikachu outfits, and they were all driving around our cars, and our AI was able to safely yield and navigate around them. We never see that in London.
Don't tell me, you just went to Japan like everybody, all the other influencers, surely. But you've also done a deal with car maker, with Nissan, and I think the idea to some extent is to sell this to automakers, not just one car maker. Is the idea to almost enclose Tesla and other kind of players like that?
Well, I think that the thing we're seeing is that Tesla's a great example, or maybe the only example in the West, of a manufacturer that also builds its AI. It's a fully vertically integrated robotics stack. But if you look at the many other, and look, there's 90 million cars produced a year. I think Tesla produces 2 million of those. So there's many car manufacturers produce vehicles, and they have this hardware, but there's a need to bring the AI to these vehicles, the embodied AI, to make them autonomous. And we want to be able to build the platform that can make different manufacturers and fleets, enable them to build incredible autonomous products. So we really see this as a platform. You can think of it a bit like the Android to a vertically integrated iPhone solution, but we want to build a platform that can enable many different manufacturers and fleets to build autonomous products. Nissan is the first car company that's announced that they'll be integrating our technology, and we're really excited about that. They're a top 10 global automaker, but companies like that, we want to empower them to build driver assistance to driverless and robotaxi products. And
you've also announced a partnership with Uber as well.
That's right. That's a really exciting one, because it'll enable us to bring these cars to not only be able to drive with robotaxi or level 4 capabilities, but of course also operate on what is the largest mobility network in the world.
So I presume then, therefore, we'll be seeing you guys running Uber taxis, no?
Well, the interesting thing is I think there's going to be a wide variety of autonomous applications, not just in vehicles with personally owned driver assistance and robotaxis and delivery vehicles, but if you think about all of the other applications that we could benefit from, whether it's healthcare robotics, domestic robotics, manufacturing robotics, there's going to be a place in the market for an embodied AI company that can provide a platform for all of those different robotic manufacturers. And I think that there's going to be a need for that kind of company to be independent of any one of these manufacturers, to be flexible, to work with the different use cases they have. But like we've seen with AI, we're just seeing multimodal foundation models bring together so many different applications. In the cognitive AI space, we've seen language, audio, video all come together, and the latest ChatGPT now combines all of these modalities. In a similar way, we see the similar thing with robotics. So if you're learning to drive a car or you're learning to move a pallet in a warehouse, both tasks you can benefit from the experience from one another. And so ultimately, I think there is going to be a place in the market for an embodied AI foundation model that can be a platform for all manufacturers. And I think Wayve has the best opportunity to be that. And that company is going to be $1 trillion company, and I really want to go and build that.
You want that to be a Wayve, presumably, the $1 trillion company. But let's unpack that a little bit, because there is this debate about so-called embodied AI. Some people also call it physical AI. And the learnings that have come out of self-driving are being applied now, obviously, in robotics. Now, we've seen the demonstrations of things like the Tesla robots wandering around, literally looking, gradually starting to look more and more human, with 2 legs, 2 arms, a head, etc. Do you think that it'll start to appear like that in our world in a much more sort of tangible sense? Or do you think it'll look different?
I've reflected a lot on this, and I see a lot of things happening in the humanoid or robotic space that are very similar to self-driving in 2017. In 2017, folks thought that self-driving was there, but actually we went through a hype cycle of learning that we needed a much more generalized solution. Self-driving started in places like Phoenix, Arizona, which is a grid-like city in the desert in Arizona in the United States, where there's grid-like streets. I think it's sunny every day except 3 of the year, and it was a very simplistic environment. But we found that those approaches that worked there didn't scale to the world, so certainly not somewhere like London. And in, say, humanoid or robotics, we're seeing similar focuses on very constrained tasks. But I would argue that
folding, washing, and stuff like that.
Yeah, or picking up a piece of sheet metal and putting it somewhere else. But actually, the real benefit here is building general-purpose robotics, building a system that can quickly learn new tasks and deal with edge cases. Even if you're picking up a piece of sheet metal and putting it somewhere else in a factory, there are going to be so many edge cases you find in actually doing that task, things that you don't expect. So in my mind, the things that we've learned in autonomous driving that really scale are, look, having a robust and global supply chain, having the hardware mature, that's a big thing. And typically you see hardware comes before software. Typically you build hardware and then many years later you exploit it with software, but the hardware in vehicles now is mature. We're seeing most major manufacturers produce mass production vehicles that have the right sensing and compute on them, cameras, radars, some of them have a LiDAR, and enough hundreds of TOPS of GPU compute on them to run AI. So stable hardware. You need proactive regulation, which we now have in self-driving. It's amazing that regulation is coming together. The UK, for example, just announced that in 2027, they're going to be able to enable robotaxi applications. We helped put that legislation together last year. But then most importantly, it's global. It's diverse and scaled access to data. And I think we've cracked that in autonomous driving because these cars can now collect data and we can learn from their experience. But the question is, how do you get that in domestic robotics? Is it real privacy challenges to work through and things like that? So my thesis is actually the embodied AI we learn from driving, I think will transfer very well to these other applications.
Now, but there is obviously vast implications. And literally just last week we saw the CEO of Anthropic talk about how the impact on jobs is going to be vast. We've all obviously seen how we thought that AI would lead to a world of huge abundance, and in fact the first thing it came for was the artists and creativity and video and images and even poetry with AI and writing. So that's obviously having an effect, and in fact some of the latest statistics talk about the destruction of entry-level jobs, even in white-collar jobs. We're talking about robotics, you're talking about moving sheet metal around. This is going to come for our labour workforce as well, isn't it? Do you agree with the CEO of Anthropic that AI companies should be taxed as a result because they're going to be trillion-dollar companies?
Look, I look at these AI technologies as the next evolution of tools. What sets us apart as a human race is we've had the wheel, cars, X-ray machines, and I think being able to trust tools to delegate tasks to them is just another step up in the productivity and capabilities of society. So I really want to see them to become an enabling force for us to free up our time to use it on what matters most and ultimately to elevate the work that we do. I think absolutely there'll be disruption. I mean, just like 30 years ago, there were many jobs have been created today didn't exist 30 years ago. I think the same will happen in the future. If you think about what's happened in, let's say, architecture, there used to be a lot of draftsmen and women that used to draw things that have been replaced by computer-aided design that now elevates the design work. And I think the same thing can be true here, that we will see, I think, significant job disruption, but I also hope that, again, it creates more value, more opportunity due to the ability to elevate the work that we do.
Is the issue, though, not that it's not good to move forward with technology and to expand the potential for this stuff, but the pace of development is so fast now. Even speaking as a long-time journalist in the space, the sheer speed at which it's developing is blistering. Do you think that society and regulators in particular, and obviously you deal with regulators, are set up to understand and deal with the impact on the economy and society at large?
I think there's going to be lots of things that we're not prepared for and don't expect, but I think that we've got so many of the world's bright minds working on this that if anything, I know there's going to be a lot of resilience. But you look at the timelines, the Industrial Revolution took 3 generations, maybe 80, 90 years, and I think we're going to see this kind of disruption over 10, maybe 20, that kind of timeline. So it is a lot more compressed. It's within a single generation, and I think that puts huge challenges on us as society, but the opportunity is immense. Autonomous driving is set to completely redefine road safety and help us drive accidents down to zero. And there's a lot of evidence of how it can improve sustainability, accelerating electrification of vehicles, as well as just improving the energy usage by maybe about 20% of the way we move around cities.
There's a big race on globally. Obviously, the United States under the Trump administration is talking about total deregulation, about AI, not stopping any of the foundational AI companies from experimenting, frankly. In the EU, they've taken a much more regulatory approach. Some say heavy-handed. The UK is taking a more, perhaps maybe middling approach, although there's some controversy about it's effectively getting rid of copyright almost, oddly enough. Strange when the UK is such a producer of culture. What do you think is the best approach, and what sort of approach would you like to see as a founder in AI and as a startup?
The interesting thing about AI regulation is I think we need to put it into 2 categories. There's general purpose AI and there's specific applications. And specific applications, whether this is in education, healthcare, or I'll talk about autonomous driving. I think actually we understand the benefits and the risks quite well. Road safety is quite well understood by regulators, and actually these risks are best addressed by subject matter experts and by specific regulation for this application. And so I think we've made great progress there. For example, the US is just talking this week about starting to bring in federal level self-driving regulation. That would be great. But across outside of the US and China, most countries fall under the UN for automotive regulation. And we've seen great work there in recent years. So Wayve actually co-chairs the industry body on this. And what we've been able to do is really push forward regulation. And we feel in a really good spot to be able to bring together hands-off driver assistance technologies and eyes-off, where you can actually take your eyes off the road and let the car drive for the majority or most of the journey. And then, of course, with robo-taxis here in the UK, we worked with the UK government last year to pass the Automated Vehicles Act 2024, which is going to legalise this. But in general, I think these sector-specific regulations are a really effective way to bring this technology to market quickly in a way that really understands the specific sector it's being applied to. I think when you think about general-purpose models that are not built with a specific sector in mind, but are tasked at general-purpose capabilities, I think there's a lot of thought that needs to go in there. But I would, I think we're seeing, unfortunately, what you don't want to see is flip-flopping of over-indexing and then pulling back the other way. For example, we may have leant too far into general-purpose regulation, which is now causing whiplash the other way. And I think there is an appropriate middle ground where we need to co-develop regulation with our understanding of the impacts of these models. And I think both are quite immature right now and need to be developed together.
Very diplomatic answer, Alex.
But without harming the ability for us to bring AI into specific applications where it can benefit so many so quickly, do that incredibly quickly.
Right.
For example, healthcare, autonomous driving, just to name some applications. We understand the risks very well in these sectors and should move very quickly.
We'll have to see how it plays out between EU, UK, and Europe, and the US, of course. But there's also a lot of talk about AGI, artificial general intelligence, and you must have some thoughts about that, when it's going to arrive, what's going to happen next.
Look, I've been helping build and looking at these models for some time, and I think brute force scaling from where we're at today is going to have its limitations. I mean, right now, if you have the right data, sure, you can learn a model that can really excel in that application. But I think that there are still really fundamental scientific breakthroughs that we should be searching for to provide a path to the next level of capabilities, let's call them. specifically being able to understand and actually model the implications of decisions. We think a lot about this in self-driving, and actually Embodied AI is, I think, a really good space for us to innovate with these models because of the pressures it puts on safety. We build our models with safety by design, where it's not an implicit afterthought of the models, but the architecture of how these systems learn ensures that they learn to make decisions they can understand the implication of, and to be able to actually drive on our roads safely. I really am building a deep level of trust for the way that our systems learn. So I think we need more fundamental breakthroughs here, but without a doubt, the progress is just getting faster year on year, and that's something that we're excited to continue to contribute to.
You're doing so well. You've raised $1 billion. Will Elon Musk be knocking on your door soon to pick you up and acquire you?
Oh, look, I feel excited that I feel comfortable to say I think we've got the escape velocity of where we are today. What I see in our product, I think it must feel a little bit like what OpenAI saw back in 2021. Look, I see the system can drive in a really general and scalable way. It's a system that, and over the years, I've really tried to let our results do the talking and not overhype this, but I do think we have a system today that can benefit folks around the world for driver assistance and is scaling up to the point where it's going to enable fully autonomous applications. And as I said, I think there needs to be a broad platform to bring this benefit to folks around the world. And there's a gap in the market for that. So I think that's where Wayve can sit, and that's what we're going to go build.
Well, we wait to see what happens next. Certainly from Europe, you're scaling an incredible AI company. But for now, Alex Kendall from Wayve, thanks so much for coming to South by Southwest London.
Thanks, everyone.
And from me, Mike Butcher, thank you.